Alright, so we are going to be looking, so we've already seen that there is the little k for the rate constant, the big K for the got a couple of things going on here, for the equilibrium constant. Remember, whenever we see the big K, the basics don't change. It is always products raised to whatever their over reactants, their coefficients raised to whatever their coefficients are. But there are different types of things that we can look at. If we go back to Pivnert, okay, if I divide this by V and this by V, and then I have my moles divided by my volume, well, that's concentration, right? So I have P is equal to CRT, the concentration. That means that my rate can work if I'm looking at partial pressures. And if you need to go back and remember what a partial pressure is, make sure that you go back and review partial pressures. There is one hitch when it comes to that. And the book goes through all the proofs and everything like this, but I'm just trying to make this as straightforward and easy as we possibly can. Instead of just being products raised to their coefficients over reactants raised to their coefficients, a lot of times you'll see Kp, because we're talking about pressure now. Still the same basic setup. Remember to keep your basic setups. Products raised to their power, reactants raised to their power, and then you are going to times this by RT, whatever the temperature is, and R is just constant, raised to the sum of the, okay, so this goes right here. Sorry, I'm out of room, but the sum of the coefficients of the products minus the sum of the coefficients of the reactants. So if I had, let's go with okay, which we've already seen. We would start out with my products, so we would go whatever my concentration of NH3 was, 2, over my reactants, and that's just a 1, and then we're times it by whatever my temperature times R, and then we have 2 minus 4, so this would be 2. Negative 2. Alright, and so that's basically if we have, and that is, so if they're talking about Kp, they're talking about pressure, you have to add this second part on. But it's still talking about the exact same thing. Where is that equilibrium in the pressure going to happen? What are we going to do with that equilibrium in the pressure?